You will already have, no doubt, heard of and potentially used sulfuric acid. It's a major chemical in multiple industries, and its production is very important and provides us another excellent example of a reversible reaction. We will also look at its uses and its application as what we call a dehydrating agent in the next video. But because of the contact process, the process of making sulfuric acid, is so long, this topic has been divided up into two separate videos. So then, the contact process is not actually a single reaction, but is, in fact, three, and only one of these reactions is readily reversible. To undertake the contact process, we require water, air, and sulfur. In this first stage, which is not readily reversible, as you can see, looking at the arrow, sulfur in liquid form is burned in the air, so just burned, to make sulfur dioxide gas, which is dangerous because it contributes to acid rain, which is a problem for the planet. Once this gas is collected, we can move on to the second stage. That being the reaction of sulfur dioxide in more of the air to make sulfur trioxide. There's the gap because as you can see here, this reaction is reversible, and specific conditions are required to make it occur. These conditions are 450 degrees Celsius of a temperature, 2 atmospheres of pressure, and a vanadium oxide V2O5 catalyst. The reasons why we chose them are set out there, but I'm just going to go into them a little bit more. The temperature chosen is for similar reasons to the temperature used in the Haber process. It is not so high that the reaction is driven the wrong way. The XO-endo relationship is the same way around you as in the Haber process, with the forward reaction being exothermic, while maintaining a good rate of reaction. A reminder here again that whether the reaction is exothermic or endothermic is independent of its rate, which will usually just be faster with a higher temperature regardless. The pressure used also helps the reaction proceed the right way, an increase in atmospheric pressure, because remember, when pressure is increased, a reversible reaction favours the side with less gas moles, which are in a 3:2 relationship here. While keeping it down to only 2 atmospheres, so 2 times atmospheric pressure, because the pressure too high actually just causes SO3 to explode, which is obviously not what we want to happen. The catalyst increases the rate, but has no effect on the equilibrium itself and does not favour either reaction in any direction, because that is achieved with the other two conditions. So then, we finish the contact process with another non-reversible reaction, that being the sulfur trioxide we just made reacting with water to make the sulfuric acid. Theoretically, this is dangerous, and this is why it's theoretical, because in the industry, the risk of this is minimised by mixing the sulfur trioxide with the already produced sulfuric acid to produce the also highly dangerous, but this time is corrosive, it's not gaseous, so it does cause less risk because it won't go up your lungs, oleum, H2S2O7. Adding water to this produces the sulfuric acid again anyway, except for every 1 mole we use in that first step, we get 2 back out in the second, meaning there is a clear net gain during this reaction. Anyway, that's the contact process. It is quite long-winded, which is why I've given it its own video, but I hope you stuck with it just fine. And in the next video, we'll be looking at more uses of sulfuric acid, both in general and then more in depth as a dehydrating agent.